Right. Hello, Professor. Welcome to our presentation on Chicago Food Safety Violation Analysis. We are Group 5. Team members Harshdeep Singh, Jil Patel, Drumil Patel, and Shrey Patel. If we talk about the project summary, this project focused on the Chicago's food inspection data to identify common food safety issue and predict the potential failure in the future by leveraging data analysis and intuitive charts. We aim to assist the health inspector in prioritizing risk establishment while also helping businesses improve food safety practice. Data set consists of 294,187 rows, 17 columns provided in a CSV format. The domain is a public health and a food safety. That's our team member, Harshdeep as a team leader, Jill, myself as a data analyst, Drumil as a project monitor and coordinator, Sri Patel as a researcher. As of now, we have completed the following task. The dataset has been fully cleaned and ready for analysis. All initial EDA has been completed. We have begun identifying advanced trend and insights. Team collaboration and updates have been managed through a SharePoint for a better coordination. The data cleaning process involved identifying and removing duplicates, handling missing values, and ensuring the dataset was in a format suitable for the analysis. This is a crucial step to ensure the accuracy of our result. Then we started doing the data cleaning, and Hasdeep will continue from here.
Hello, Professor. I hope you're doing good. Myself, Harshdeep Singh. I'm the team leader of this project. So we started with the data cleaning process earlier in the start date of that project, and after that we did some cleaning process, and we removed missing values and some outliers as well. Previously, the data was too big and there were a lot of missing values, but we managed to remove them all, and we managed to do the EDA analysis afterwards, the cleaning process. Can you move to the next slide? Yeah, as you can see, after the cleaning process, we have nothing in the missing value. As you can see, zero all in every column, we have zero missing values. So can you move to the next slide, please? After that, we started doing some visualization. First of all, we started with the basic visualization, that is univariate. As you can see, the first distribution of inspection result. This is only using the single variable, the inspections results. As you can see, the pass ratio is the most out of it, but the fail ratio is also almost half of it. So it's a big concern about the inspections and the facility type that to be checked regularly. Can you move to the next slide, please? And we did some other basic analysis that is also univariate. Can you move to the next slide, please? After that, we managed to do the bivariate analysis, in which we used two variables. First of all, we did the inspection result for bakery, that is 50% pass ratio only, and for the restaurant it's also 50.9%. So as we can see that half of the account were getting failed in the inspections. Can you move to the next slide, please? After that, we did the multivariate analysis by using the geospatial features. As you can see in this, we are looking for the risk factors across the Chicago city. As you can see, the closer to the city downtown, the more risk is. As you can see, as you go a little far from the city downtown, you can see the risk is green, that is low risk. Can you move to the next slide? After that, after doing the basic analysis, we did the feature selection and engineering. In this, we did some making of new columns in which we can check the average inspections by month, and we also did the encoding for the risk as well. So as you can see in this table, we did the risk level with the numbers itself. As medium would be around from 1.2 to 1.5, the low would be 0 to 1, and the high would be till 2. So as you can see, the bakery is at medium level, and the hospitals are at highest level with the average risk encoded 2. Can you move to the next slide, please? Yeah, this is the basic structure in which we can see everything for those five facilities. For the restaurant, the main risk is 1.80. That is pretty much high, as this is showing by red. Wherever the grocery store is at green, because the average risk is 0.96, so risk is low. But the for bakery, it's medium. So the top riskiest facilities are restaurants, schools, and hospital, which we have to look over. Can you move to the next slide? Then we tried some line chart to analyze this more. Then we checked the average risk over time as per the facilities. As you can see, for the restaurant, school, grocery stores, hospital, and bakery, grocery stores are little variable but stays below the risk level. Hospital are the above of everything, and the we can have steady flow in the restaurants as well. So as you can see, for risk level is a little bit same for school, restaurant, and hospitals. However, the bakery is at the medium level. That doesn't mean we have to neglect it, but it's still far better than restaurants and hospitals. Can you move to the next slide, please? As we can see, the monthly inspection count, there's a uh, bit variation at the end of the year. Like you can see in 2025, the inspections are down. I don't know why, but before that, there was a steady count of inspections. Like a lot of inspections have been done in 2016, but after that they went down a little, but stayed same till 2024. But in the later 2025, the inspections went down. Can you move to the next slide, please? So this is the overall risk level composition by facility type. As we can see, yellow considered medium, red is the high, and green is the low. In bakery, we have around 50% of bakeries at medium level risk and 40% at high level risk, and only 2 to 3% is a low risk. However, the grocery stores are pretty much same for each risk level, and in hospitals, almost every hospital is at high risk. However, the restaurant is showing that 80% of the restaurants are at high risk, and only a few ratio of restaurants are safe. Same with the schools, most of the schools are at high risk as well. Can you move to the next slide? So, yeah, from this slide, my next team member will continue. Thank you, sir.
Hi, my name is Dromil. So, in this particular slide, that this slide shows the main challenges we face and how we solve them. We had some data quality issues, as we already have in all these projects, and so we used to clean scripts to fix, but all these data challenges issues. The large data set was slow to process, so we used filters and queries. For a feature section, we created new useful variables, and to manage time, we divided tasks and give weekly updates to stay on track. And next one, please. Current recommendations, we are continuing improving visualizations and dashboard, as we founding some problems and issues. We also being predictive modeling. We also some prepared some summary reports for to get some insights and the presentations also. We keep tracks on the progress and updating the SharePoints regularly. Next one, please.
So, good morning, Professor. My name is Sri Patel, and I started with the recommended for the next phase. In the next phase, our main focus will be on the starting predictive modeling using the machine learning. So we will test the validate like this model to ensure accuracy and finalize our interactive visual dashboard. By the end of this phase, we aim to have a strong predictive system ready for the final presentation and the submission. Next, please. So like this is the our project theoretical costing. Here we can see our planning. So there is a timing and the cost distribution for the project. Initially, we estimated about the 16 hours for the total work at the rate of $25 per hour. It means the total cost of our project is $1,500. This breakdown help us to plan our phases such as requirement gathering, designing, development, and the testing. Next, please. So, uh, can you go the forward, please? So,
That
this is
one,
our,
right?
sorry, Ji?
That one, right?
Yeah, it is right. So like this is a project cost summary. However, we can compare our theoretical cost with the actual hour, which is way better than our prediction. We spent like only 25 hours complete to complete this work at the cost of only $625. This show that our actual execution was way better than our plan, which is possibly due to the time management that we did in the designing phase. Next, please. So, in conclusion, we successfully complete the data cleaning, exploration, and visualization for Chicago food inspection data. Our dataset is now ready for predictive analytics, which will help in identify risky restaurant earlier. So the ultimate goal is to support public health by improving the food safety standard through data-driven insight. So this is our work that we did before the midterm. Thank you, Professor.
Thank you, Professor. Now, at the end, let me show you our coding work. So that's where we code in a Jupyter file.
So yeah, Professor, in this for the cleaning type, we use the NumPy and Pandas library. For the visualization, we did we use Seaborn and the Matplotlib library. So that's all we did in this.
Yeah, that's all the
Yeah.
EDA and all the charts, that all the analysis that we have done. That's a feature engineering.
Thank you, Professor.
Thank you, Professor.